Hi, hello, coming to FIBE Advanced Academy. Next one we will be discuss one small example for differentiation. Here problem is given f of x equal to root x, where x greater than 0, prove that f is the differentiable on 0 comma is infinity, and is we are going to find out f dash of x. So we go now that f dash of x equal to f of x plus h minus f of x divided by h. This is the limits to equal to 0. So but here let x belongs to 0 comma infinity is what is the x belongs to 0 comma infinity where h not equal to 0 and that h equal to less than h. Why? Because here always x value is less than to h value, so that's why the h equal to where less than equal to h. Therefore f of x plus x minus f of x divided by h, this is the formula, basic formula. Therefore root of x plus x minus root x divided by h, root of x plus h divided by minus root x divided by h, where root of x plus h minus x into root of x plus h plus h. Why? Because these are we are applying to a minus b whole square, where a plus b into a minus b. The same formula we are applying here, h into root of x plus h into root x. Therefore limits to h into 0 here 1 by root x plus h equal to root x. These are the condition finally will get. The same way we are applied to the limits to h into 0, where f of x s plus h minus f of x divided by h equal to 1 by 2 root x. We are going to prove that what is this, f of x equal to root x. F of x equal to root x. Here f of x is nothing but root x. So same way we are applying here. Therefore f of x equal to 1 by 2 root x, where the x belongs to 0 comma infinity, where here x is a 0 up to y value is up to infinity. So this is the one small example. We will take one more example. Next problem is if f of x equal to here if f of x equal to 1 by x square plus 1, x belongs to R, where prove that f is the differentiable on the R and find the we are going to find the f dash of x. What is the f dash of x basis value? We know that f of x h plus h minus f of x divided by h. These are basic formula, where s belongs to R, h not equal to 0. Why h not equal to 0? In case we will take h equal to 0, these are not defined. That's why we are applying here h not equal to 0. Same way f of x plus h minus f of x divided by h equal to 1 by h is the common, where f of x plus h is nothing but 1 by x square h whole square plus 1 minus 1 by x square plus 1. Understand? The same way we are applying here from this equation, we are applied to the minus h 2x plus h. Whenever we are applied take LCM, we will get here h is the common in the numerator. So minus h into 2x plus h divided by h into x square plus 1 into x plus h whole square plus 1. So this is the equation. Whenever we are compared to this equation, when second one is minus 2x plus h, next one divided by x square plus 1 into x plus whole square plus 1. From this equation, why we are applying this one is this value, h value, they both are cancelled. In numerator denominator, h value is cancelled. We'll get and finally minus 2 into x plus h divided by x square plus 1 into x plus whole square plus 1. This is the value. Next one is we are applying here limits h into 0. We are applying here. So limits h into 0, where x plus h minus f of x divided by h is the formula. Therefore, what is the f of x h plus minus f of x divided by h? This given is f of x is 1 divided by x square plus 1. So we are applying h into 0. So we apply here. So finally we will get value minus 2x plus h divided by x square plus 1 into x plus h whole square plus 1. So in this h plus we are applying 0, we will get minus 2x divided by this x square plus 1 as it is wrote down. Next this value is x plus 0 whole square, where x square. Understand? So plus 1. So this one is we are multiplied x square plus 1. Next x square plus 1 will get x square plus 1 into x square plus 1, x square plus 1 whole square. So this is the value. Whenever we are applying limits h into 0, will get value is minus 2x divided by x square plus 1 whole square. Next, where we have deferred the x value, we have differentiations of the x value with respect to function. We are f dash of x equal to minus 2x divided by x square plus 1 whole square. There where here x belongs to R. So this is the one more example for the differentiation. Will be discussed next 4 examples. and next more topics will be discussed. So next will be discuss one small theorem. This is a theorem. What is the say of the theorem? Let I an interval or this function is I to R. Here where is I to R is nothing but integers to rational number. He is on the A belongs to integer if it is differentiable at A. So then the function is continuous at A. So I hope these are very easy, but understand I hope. But here suppose we are assume that f differentiable at A, limits we know that function, the limits is x tend to A, x tend to A, where f of x plus h, but we are applying to f of x tend to A. So therefore f of x minus f of A divided by x minus A, f dash of A, where this f of x minus f of A equal to f of x minus f of A divided by x minus A into x minus A. I hope this is understand. F of x minus f of A divided by x minus A into x minus A. Where this, what is the condition? The condition is x not equal to A. I hope understand this one. This condition is x not equal to A. Therefore, limits x to x equal to A. F of x minus f of A, the both are cancelled. Will get f of not equal to A into A equal to 0. This is the condition. There f of x equal to f of A. This is the condition. They both are equal. Then finally limits x tend to A, where f of x equal to f of A. Understand this one. This primary of function is continuously at A. So this is the theorem. Next very important theorem. The theorem is said here the derivative of the sum and differentiations of the two functions. These are very important function in the expression to differentiation whenever they given two functions. So whenever we are going to sum and the differentiation two functions. So example we are going to prove that. Example is, so f equal to u plus v. This is a condition. F equal to u plus v. But here must and should differable is its function is continuous det h, this det h. Therefore f of x plus h minus f of x divided by h. Therefore this one written as u of x plus h plus v of x plus h. This function is we are apply here u and plus h. So therefore v of x plus h minus u of x minus v x f x divided by h. But here this value is we are dividing two terms. These two terms is u into x plus h minus ux divided by h. Next term is plus v into x plus h minus vx divided by h. There here u dash of x plus v dash of x and h tends to 0. This v of differable x and f of x u of dash of x plus v dash of x. So this is a condition. Therefore a u plus v f dash of x into v dash u dash of x plus v dash of x. So this is a condition. Whenever we are applying u plus v dash of x equal to u dash of x plus v dash of x. So this is the formula we are going to prove that these are very important of whenever they given the two differentiable of conditions we are applied to the sum and two functions in the expression differentiation. These are theorem. So next theorem will be discussed. Here this what is the theorem? The theorem is nothing but the product of two differentiable. The product of the derivatives of the product of two functions. So we are before you have discussed the sum of two functions, but here the product of two functions will be discussed. This function is u and v, where the non-zeros is det h. The same way f of x plus h minus f of x divided by h equal to u of x plus h into v of x plus h divided minus u of x into v of x divided by h. Why? Because these are product. That's why the both functions are multiplied. What is the function here? First function is u into x plus h. Second function is v into x plus h. The same way u of x next to v of x. So this is the function divided by h. Therefore this written as u of x plus h into v of x plus h divided by h plus v of x into u of x plus h minus u of x divided by h. So here this we are dividing two terms. The same way we are applying v, u is differable. Here what is the differable? U is differable with respect to x. U is differable with respect to x or at a. X. Therefore the limits h tend to 0, the limits h tend to 0, the u of x plus h equal to u of x. U of x plus h into u of x. This is a condition. But here this function is, we are applied u of x into v of x, v dash of x plus u dash of x plus u dash of x into v of x, where h into 0. Understand? Therefore, this function u and v, the differable with respect to x, will get u v of dash x equal to u of x v dash of x plus v of x u dash of x. So these are theorem, we have proved that these are very important whenever the given two functions are product of the functions, especially in differentiable. Okay. Next theorem is, the theorem is said the derivative of the two functions, so reciprocal. These given two functions are reciprocal. Whenever we are going to discuss, the topic is whenever the given two functions is reciprocal, the what is the function will be discussed. The here f is differable yet x. Therefore, here condition is f of x not equal to 0. This condition is clear. This f of x not equal to 0. This condition. Therefore, here function is g. The g of x plus h minus g of x divided by h. Therefore, these are reciprocal. So, reciprocal is nothing but 1 by f of x plus h minus f of 1 by f of x divided by h. This values will get f of x minus f of x plus h divided by h into f of x into x plus h, f of x plus h. Therefore, we will take this value is f of x plus h minus f of x divided by h into 1 by f of x into f of x plus h. These are will take in yes, LCM is will take here. These are LCM. Therefore, here we are applied the two functions, the reciprocal of values, we are applied to the limits h into 0. Limits h into 0 we are applied here. Therefore, f of x plus h minus f of x divided by h equal to f dash of x, and the limits is limits h into 0 f of x plus h equal to f of x. This is a condition. Therefore, we are applied the function is g of x plus h minus g of x divided by h, limits equal to, therefore, f dash of x. This value is g of x plus h minus g of h equal to f dash of x. Therefore, h equal to limits h into 0 will get f dash of x whole square. Therefore, as the h into 0, g dash of x, h into 0, these are g dash of x equal to f dash of x divided by f dash of x whole square. So these are condition. Actually, this function is reciprocal. Therefore, 1 divided by f dash of x equal to minus f dash. Why? Because we are taking reciprocal of the h into 0. That's why we are taking minus of f dash of x divided by f dash of x whole square. So this is the theorem. This theorem is very important, and especially whenever the given two functions of the we are taken, they will apply to the derivative, especially reciprocal function. Okay, this is very next theorem is the derivative of the function, the coefficients. The derivative of the coefficients of two functions. How to we are divided, going to prove that will be discussed, where the proof is 1 by, these are previous the function. So 1 by v whole power x equal to minus v dash of x divided by v of x whole square. Before you have discussed two functions. This function is minus f of x divided by minus f dash of x whole square. So this is the function minus f dash of x divided by f of x whole square. This function they are same apply here. 1 by v whole power dash equal to x equal to minus v dash of x divided by v dash of x whole square. This function is u by v. Here given coefficient. We are given the derivative of the coefficient of two functions. So that's why we are taken u divided by v dash equal to x equal to u into 1 by v of dash of x. U into 1 by v of dash of x. Same way, this one is u dash of x into 1 by v of x plus u dash of x. Next 1 by v of x. This formula we are applying. So whenever the sum of the given two terms, derivative of sum of two terms. Therefore, here u dash of x we will take in common. 1 by v dash of x equal to, what is the, before you have said here, 1 by v dash of x equal to minus v dash of x divided by v dash of x whole square. So this value we are substituting this value minus v dash of x divided by v dash of x whole square plus here u dash of x is the common. So 1 by v dash of x is nothing but u dash of x divided by v of x. Okay, so therefore from this equation, from this above equation, we'll get 1 by v dash of x whole square. Here denominator is, the both are, what is the denominator? Here first term v dash of x whole square, in second term v dash of x. Same way here we are taken common in from denominator, so 1 by v dash of x whole square into v dash of x u dash of x minus u dash of x into v dash of x. Therefore u divided by v dash of x equal to v of x into u dash of x minus u dash of x into v dash of x divided by v of x whole square. So this is the proof whenever they given these two functions of reciprocal value of the derivative of the differentiation, whenever they given this theorem. Very important and very easy problem. So will you have any doubt is there in this problem? Want to ping me in the comment section. I will be clear any doubts in the expression and differentiation. Okay. So next theorem is the derivative of the inverse function. The derivative of the inverse function. Whenever they given two functions, what is the derivative of the inverse function will be discussed. So what the proof is, f of x plus h minus f of x divided by h, where h tends to 0. So whenever we apply the limits of the h tends to 0, this is a condition. Therefore, we know that f dash of x equal to not equal to 0. This is a condition before you have discussed whenever we are taken two functions of the product of the zeros. Right? Same way, f dash of x not equal to 0. Therefore h divided by f of x plus h minus f of x. Therefore is to 1 by f of dash of x as h tends to 0. This is a condition. Therefore we are differable. Before you have differable the function, we are differable g. Differable g of y plus k minus g of y divided by k. Therefore h equal to h divided by g of x plus f of x plus h minus f of x. Therefore g of y plus k minus g of y divided by k, this is to 1 divided by f dash of x, as the k is to 0. K ends to 0. K ends to 0. Therefore the g differable, the function f of x and g dash of f of x equal to 1 divided by f dash of x. This is a condition. Therefore y equal to f of x and x equal to f dash of x. Why? Because here x equal to, this function is transpose that side, will get y equal to f dash of x. Therefore x equal to f inverse of y. So this is a function. Therefore, and the derivative of this function will get dy by dx equal to 1 by dx divided by dy. So this is the theorem, the final value. Therefore this theorem is derivative of the inverse of the function. We are set to clearly. Therefore x equal to f inverse of y and the dy by dx of 1 by dy by x of, this is a condition.